Vertical and horizontal translation. You've just been doing that. That's what you've been doing. Didn't have a name, but now it has a name. You've been shifting these shapes, transforming them. The general sort of subject that we're under, or category that we're under, is transformations. And there are different kinds of transformations. The ones we're going to focus on today are called translations. So that means that you're moving, you're not changing the shape of the object at all, right? You're just moving where it is from one place to another. And you can either do that horizontally or you can do it vertically. So that's what this is saying. It's a type of transformation. Definition is the movement of an entire graph upwards or downwards. To do a translation up or down, as it says here, you take the function and you add on some value. C. C is a value added on or subtracted from the entire function. And that's a vertical translation. So when you're doing something with your y's, think of y and f of x as being the same thing. When you're doing something to your y's, you're doing a vertical translation. So for example, the function is f of x is equal to x squared, g of x is equal to x squared plus 2, and h of x is equal to x squared minus 4. These are all on the same grid. So the original function, and I'll just point to it right now, the original function is the x squared function, this line right here. Oh, sorry, this line right here. That's my x squared. Let me put that in red, actually. So this line right here is my x squared function. Which of these lines do you think represents the x squared plus 2? Right? Which of these three lines do you think would be x squared plus 2? Remember, I've taken my y values, x squared, that's your function, and I've added on 2 onto it. So of those three functions, which one do you think is the x squared plus 2? Which one translated it? Yes, please go ahead. The one above it, all right? So I'm put that in green, right? So this one here, this represents the x squared plus 2, right? Every single point on the graph just simply got shifted up by 2. We're going to look at what happens to the coordinates in a minute, because you just did that on Desmos. The x squared minus 2, I put that in yellow, right? X squared minus 4 is this line right here, right? So that's the one that shifted everything down. Didn't shift it left, didn't shift it right, just shifted everything down. Now, what does that mean in terms of the coordinates? Well, let's get to that right now. For a vertical translation, the x values are unaffected. Let me say that again. For a vertical translation, vertical means you're really working on the y coordinates. Your x coordinates are not affected. So every single x stayed where it was. So in my little chart right here, I'm just going to repeat the x's. Minus 3 used to be at 9 in the regular y equals x squared function. So minus 3 is still there. Minus 2 is still there. So just keep repeating all of these numbers. Those numbers are not affected. X's remain the same for a vertical translation. Each y value, what do you think I need to do to each y value? What's the rule for each of the y values? What do you think happens? Yes, Jay? Just simply add 2. So 9 goes to 11. 4 goes to 6. 1 goes to 3. 0 goes to 2. 1 goes to 3. 4 goes to 6. And 9 goes to 11. I saw Naomi's hand up as well. I presume she was going to say the same thing. That's all. There is your vertical translation up by 2, right there. So I'm going to write that above here. I know it's okay for you to use the abbreviations that I use. So under transformation, I'm going to put VT, which means vertical translation, up 2. That's the first one. And there you go. That would give us the green line. Well, the one that I just marked off with green. And you can check the points for yourself. The point minus 311 would be on that line, but actually it's off the charts. Minus 2.6 is on the line though. Minus 2.6 is right there. It's on that green line, and so on and so forth. Everything went up by 2. Now let's get to the next one. What happens to my x values for x squared minus 4? What's going to happen to my x values? Tell me out, folks. What's going to happen to my x values? Wanya. What's that? Not to the x values. Not to the x values. What do you think happens to the x values? Stays the same. X values don't get affected if all I'm doing is a vertical translation. Vertical affects my Y. So for my X values, I'm going to put them back the way they were. -3, -2, -1, 0, 1, 2, and 3. Now the answer I just got from Wanya, put the phone down for me, please. Put the phone down. You don't need that. Oh, sorry. I thought it was the phone you were playing with back there. My bad. All right. Whenever I see students starting to, do this, I just kind of figure that it must be phone they're playing with. My apologies, sir. Yes. What happens to the Y's? You subtract 4. So every single Y goes down by 4. So my 9 goes to what? What am I going to put for 9? 5. And what is the next one? My 4 goes to what? What happens to the 4? 0. Keep going. Put all the other numbers in for me now. And then you can check back. Yes, question?
So it's only the vertical translation that the X value doesn't change?
Correct. Exactly. So the question I just got, let me repeat it so it ends up on the recording, is it's only for vertical translations that the X value doesn't change. Yes, if it was a horizontal translations, yes, the X value would change. And if it's both, then X's and Y's would change. Okay? Sorry, you had a question as well, Sarah? No? Okay. All right. So keep putting all those Y values in. Finish up the Y chart. All right. No, this is a phone this time. All right. You're finished? All right. Well, then just stay with us. All right. You're going to get distracted by that. Don't do that. All right. Okay. So finish up that chart. And let's talk about horizontal translations now. All right. Let's get to horizontal trans. I'm not going to finish the chart because you can do that on your own. All right. Put all the other numbers in. Just simply take 4 from every single number there and keep going. Now, horizontal translations. For a horizontal translation, the difference is that you don't take the whole function, in the case of x squared, for instance, and you add on or subtract something from the function. You do something to the x first before you do the function. Right? What do I mean by that? The function used to be x squared. And what you see here, it says y is equal to f minus d, where d is a value added or subtracted from x. Meaning, before I even square the x, before you even square it, so the function is x squared. Before you square, you add something onto the x first. That's going to give you your horizontal translation. But I'm going to warn you, horizontal is backwards. What do I mean by that? It's not what you expect. If I add 2 to my x before I square it, which is going to give me the horizontal translation, I actually move to the left. That's why I say it's backwards. It's not what you expect. Adding 2 to each x before I square it gives me a horizontal translation of 2 to the left, not to the right. You're probably going to think, oh, it should be going to the right. It's because I'm minusing the d. And because I minus a minus, it becomes a plus. Okay, yes? It is kind of like when you're doing vertex form, yes. Oh, by the way, let me put on top here that the second one is a VT again, but this time it's down by 4. All right, so you should put that transformation in. So you can go back later and you can see what that was. So look at these translations now. These are not translations going up or down anymore. These are translations moving left or right, kind of like what you were doing a few minutes ago on Desmos. So you're shifting either left or you're shifting right. But be careful, because you're going to do something. The function is x squared. But before you get to the x squared, you do something to the x first, and then you square it. That's the difference. When you're doing vertical translations, you did the function, then you added on something, or you subtracted something. Now you're taking the function and doing something to the x first, adding on something to the x, or subtracting something from the x, and then you do the function. In this case, it's x squared. So what's going to get affected this time? Is it going to be my x's or is it going to be my y's? What do you think? Okay, excuse me. So Chair, what do you think? It's the x's. But what happens to the x's if I'm saying this is x plus 2 squared, what do you think happens to each of the x's? That's the thing. Yes, Aaron. Say it again. You said increase or decrease? You minus it by 2. That's exactly right. Aaron is right. Right? That's the part that surprises people. Let me tell you again, horizontal is backwards. And in fact, it's going to get even more backwards when you get to compressions and stretches. You're going to be looking at this and thinking, why is it this way? This doesn't make sense. Well, horizontal, always backwards. So I'm going to take my x's, and because it says x plus 2, which means I'm shifting to the left, it's a horizontal translation. Each of my x's goes down by 2. Gets subtracted by 2. So minus 3 goes to minus 5. Minus 2 goes to minus 4. Minus 1 goes to minus 3. Minus 2. Minus 1. 0. And 1. I subtracted 2 from each one. Right? Which means, yes.
That 2 is from the x plus 2, right?
Correct. Correct. It's the opposite of what you think. So this one is a HT left 2. Left 2, not right. So which one is represented by that? Is this one over here, right? So this x plus 2 squared, let me color code it again, actually. This x plus 2 squared is actually this line right here. It's shifted to the left. Now, what happens to the y's is the next question. What's going to happen to y? Excuse me, yes, Shreyash. They stay the same. You're not, because it's a horizontal translation, horizontal has to do with the x-axis, your y values are unaffected. So my y values are still 9, not sure why it's in red, but anyway, 4, 1, 0, 1, 4, 9. Those do not change because I'm not doing a vertical, which would affect the x's. I'm doing a horizontal, which affects the y's in a backward manner, right? If I want to shift to the left, I add 2 to each of the x's, and then I square. Okay. 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 If that made sense, let's try this on the other one. Look now at the second horizontal translation, which is x minus 4 squared. What do you predict is going to happen when you minus the 4? Yes, Masumi. Good. And what is going to happen to the actual shape? Is it going to shift? It goes to the right by 4. That's exactly right. So what that means is this x minus 4 here, which I'll color code again, this thing here is actually this line, the one that got shifted to the right by 4. So what Masumi just said is that every x value, right, although it says minus 4, what happens to each of my x values? What do you think? What happens to each x value? What do I do to my x values? Yes, AJ. You add 4 this time. You're shifting to the right, so you add 4. So I was saying that we are transforming, the one in red is being transformed 2 to the left, and the way we did that, even though it said x plus 2, it's the opposite of that, because you're minusing a minus 2, which means that you're actually shifting to the left by 2. And what happened to each of the x's that they went down by 2? Minus 3 went to minus 5, minus 1 went to minus 4, and so on and so forth. The y's do not change, okay? And that results in this red graph that we're looking at here. For the green graph, I want to shift 4 to, well, you tell me, right? What does it look like is happening to the green line? Yes, Shreyash. 4 to the right. So it says x minus 4, so the opposite of a minus is a plus. And what happens to each of the x's? Well, you tell me. What happens to each of the x's? Yes. No, you don't. No, you don't. What happens to each of the x's? Yes. Nothing. The x's. Okay. So the x's are going to be repeated. We're just going to simply put all the... What am I doing here?
The y is the same, the x is the same.
Let me apologize formally to you here. Okay, my humblest apologies to you, sir. Yes. Yeah, when you're shifting horizontally, yeah, okay. When I looked at the graph, when I looked at the table, I realized my error right away. The y's do not change. So we can just put those y's back again, right? Those y's, I put that in green, stay exactly as they are. So it's still 9, it's still 4, it's still 1, it's still 0, it's still 1, it's still 4, it's still 9. But now my x's, sorry, what happens to my x's again? It's, well, it's what? It's, right. What happens to each of the x's now? Yes? What's that? What Chase said earlier. We're going to add 4. So the minus 3. Hello. Stop doing that. Don't do that. The minus 3, we'll go back to the original, by the way. The minus 3, we're going to add 4 to that. So that's going to become 1. The minus 2, we're going to add 4 to that, which is going to become 2. And then 3, and then so on and so forth. 4, 5, 6, 7. And if you look at the graph itself, the graph should reflect that. No, it doesn't. What did I do wrong? 7. Oh, that should be 941014. Oh, that's a 9. Oh, okay. So 7, 9 should be on that graph somewhere. 7 and 9 should be on that graph somewhere. Okay? The one that got shifted to the right by 4. So again, right by 4 means I'm going to represent it as x. And again, I want to make sure you understand something. Before we square, the function is x squared. Before we square, we do something to the x first. We minus 4 from that x. Okay. Hoping that that's clear to everybody. Here's a summary table. If the function, just a regular linear function, f of x, and I do want to do a vertical translation, I could just add c, some number c to each of those. If it was a quadratic, then I would just add c. So every one of these just simply add c, right? If it was a horizontal, before I do anything, I just simply minus a d from it. So it's x minus d squared. X minus d, then square root. X minus d, then cube root. X minus d, and then I take 1 over that, and so on and so forth. If it was an exponential, and so on. So the conclusion to that, if the c is greater than 0, it's a vertical translation, c units up. If it is a negative c, then it's a vertical translation, c units down. If d is greater than 0, there's horizontal translation to the right. If it's less than 0, then it's to the left, and so on. Now, what if I said to you, I need to transform these two lines. What would you think, first of all, is the original function here? Let me mark it off with red. Anybody know what the equation of that red line is? What does it look like? Think back to when we were looking at all those different functions earlier on. What is the equation of that line? Yes, the chair. Yes, y equals x cubed. That's correct. So the red line is y equals x cubed. Now, let's see if we can figure out how we can write a new equation for this function where it seems, I'll tell you what it seems like has happened. It looks like this function got shifted to the left by 2 and up by 4. Can anybody predict what that equation might look like? I want a horizontal translation to the left by 2. Then I want to go vertically up by 4. Can anybody predict what that equation might look like? Yes, Aaron. Okay, let me see what you're saying here. So f of x equals, go ahead, x what? X plus 2 in brackets to the power of 3, because it's still a cubic function, right? And then you said plus 4. I agree. Absolutely agree. That, if I were to put this on Desmos or some other thing, it would look exactly like what you just said, right? It shifted to the left because of the plus 2, and it shifted up because of the 4. Well done, Era. Look at the second equation now, second graph rather. What function do you think is represented by that V shape right there? Yes, AJ. Say it again. Absolute value. Take out the earbuds for me, please. So remember, absolute value looks like this. I'll use a different color. This. Y equals x with the 2 bars around it. All right? So tell me what happened to the absolute value function. Look at it carefully. What do you think happened to that function? Right? How was that function translated? And how would we write the equation that would make that magic happen? Come on, folks. What do you think? Anybody? Yes, Manuel. Okay, 3 to the right and 6 down. I agree. But how do we? You're right. In fact, let's write that down. So 3 to the right means ht right by 3. And then vt down 6. By the way, this one here, which we didn't write before, This was a HT left by 2, and this was a VT, hold on folks, a VT up by 4. So try to get used to the language that we use when we describe these transformations. Okay, let's get to the actual equation now. All right, I want to go right 3 and I want to go down 6. How can I rewrite the equation? I think you know. Something tells me you know. What do you think? So put the absolute value bars, right? So f of x, let's call it g of x this time. G of x is equal to, say it again, x minus 3, good. And then the minus 6 on the outside. That's what's going to take it right 3 and down 6. Right? The minus 3 is what takes it to the right. The minus 6 is what drops it down. Okay. All right. Let's get to the next page now. In the function x is shown below, apply each transformation by determining the image points for A, B, C, and D. So this is something you're going to do now, right? If it says f of x minus 2, let's describe what this is. Let's describe what that is. Let's describe this. Let's describe what that is. I'm going to draw one for each one of them. Let's start with the first one. What do you think the g of x function is doing? What is happening to the... So this is the function. This strange looking set of points is the function. What do you think the f of x minus 2 is doing to that function? What do you think that means? The f of x and then the minus 2 at the end. What do you think is happening there? All right? What does that notation suggest? Yes, Sarah. It is a vertical translation, and I want you to use the phraseology, the phrasing, VT, vertical translation, down 2. Okay? So the first one is a VT down 2. Now, we're going to get to the points in a second. The image points, A, B, C, and D, right? But do we all accept what Sarah just said? That's what this means. When you see the f of x and you see the minus 2 afterwards, it means you're going down by 2. Now, let's see if we can make that magic happen. What are the coordinates for the first point? A. Give me the coordinates for A. Let me go to Akifa on that one. Give me the current coordinates for A. What are the current coordinates for A? What's that? Yeah, no, give me the coordinates. I want to know the x and the y right now. Before we do anything, what is it right now? Yep. -1, -1. Okay, let's write those. Let's put a little table here. So A is -1, -1. And let's put the ones for B as well. Let's just list them all out, right? Athuzan, what's B? Give me the coordinates for B. The current coordinates, what is it right now? No, sir. It's the other way around. X comes before Y, remember? Right? So 2, 5. Let's get to C now. 1 second, thank you. Let me go in the back there. I need my seating plan as usual. Let me hear from Anjali. Anjali, can you give me what the x and y coordinates are for C, please? For C is 5 and 2, good. It's actually the opposite of the other one. And then for D, let me go to Hashim in the back there. Can I get the coordinates for D, please? 10 and 4, okay. Perfect. Okay, now here's the thing. Let's take the A and let's do what it says for the first one, which is the f of x minus 2. It says down 2. How is that going to affect my A point if it says down 2? Can you help me with that, please? What does it do to the coordinates? The coordinates for A right now under number 1 are -1, -1. What's going to happen to that A point under the first one? It says down 2. Yes, go ahead. Say it again. What's going to go to minus 3? The y is going to go to minus 3, or is it the x? Which one is it? Which one is going to change? What's that? The x? Sound like you're guessing. Sound like you're not sure. I want you to be sure. I want you to reflect on that. Think about that before you answer again. Is it the x or is it the y? We're trying to do a vertical translation. Think of which axis is the vertical axis because that's the coordinate that gets affected. Okay? The y. Perfect. Anything going to happen to the x? No. So we're going to leave the x as it is. So the x is still going to be minus 1. But what happens to my y again? It said it goes up or down, you said? It goes down to negative 3. You're going to take 2 from that to negative 3. So what I want you to do is I want you to put that point on your graph right now. Put it in pencil because you're going to have to do it a couple of times, right? Or you may even make a mistake. So put that point on for me, please. Okay? The B point used to be 2, 5. Okay. Let me go to Rosie now. Rosie, what happened to that B point? How is it affected? It's very similar to what you just heard about the A point, right?
2, 3.
Okay, so you're saying that the x value doesn't change? Is that what you're saying? Good. X value does not change. But the y value is going to go what? Up or down by is it going up or down? Are we adding or subtracting to the y? We're subtracting 2, which you said makes it 3. Okay, let's get to the C point now. Then you're going to put that point on, right? So I'm going to put that point on as well. You can put that on your thing as well. Let's get to the C point now. The C point. Let me go to Shaluja on that one. Shaluja, excuse me. What's that? So is a 5 going to still be 5 or not? It's still 5, but it's going to go to 5, 0. That's what you're saying, right? Good. And finally, what happens to the 10, 4? Let me go to Abdullah on that one. Abdullah, what happens to the 10, 4? It goes to 10, 2. Good. Okay, go ahead and put that on now. And then just join the points together into a nice sort of smooth curve. And you should see that the whole thing basically went down by 2. Okay? Just join your lines together. I want to see everybody do that now, please. All right? Your new image is called the image. Image means what happened to it after you did the transformation. I'd like you now to tell me what happens with the f of x minus 3. What does that mean? What's happening with the f of x minus 3 this time? Yes? HT right by 3. It's a horizontal translation to the right by 3. HT right 3. So how is this affecting our coordinates? Not there. Thank you. How is this going to affect our coordinates? Thank you. How is this going to affect our coordinates? All of the original coordinates that we had. Let me show you the coordinates again. According to what Sarah just said, it's going to be a horizontal translation. So what happens to all of these coordinates that we started off with? Okay, good. You add 3. So take each of your x values, right? Yeah, I'm going to drill you. I'm not going to apologize for that, all right? Take each of your x values, add 3, keep your y values the same. You're trying to translate horizontally now. So for instance, this first point here should become, remember, it's the x values that are going to change. This a value is going to be, you're adding 3 to each one, so that's going to give you 2 minus 1. That's your new a. That's your image of a. Do the same thing to the b, do the same thing to the c, do the same thing to the d, and then join the points up again. It should now shift, not up or down, not like it did the first time. It should be shifting to the left, sorry, to the right by 3. Okay, that's what's happening. Should be going to the right by 3. Let's see. Abel, describe what's going on in the third one. What's going on in the third one? Let me move all of these up here. What's going on with this? Okay, let me move this one up first. Let's move that one up, give us some room. What's going on with the third one? Mm-hmm. Good. Okay, write that down. HT left 2. Anything else? VT down 1. Excellent. Excellent. Okay. So that means that both the X and the Y have to be adjusted. All right? That's what it means. It's not just the X, it's not just the Y, it's both. So I'm going to let you figure that out now. Right? And then I want to see, I'm going to come around in a second to look at it. I want to see what that looks like on your graph. This should be a shift to the left by 2. Left to right means X values get affected. A shift downwards of 1. The Y values get affected. So it's two things going on at the same time. All right? So I'd like to see you do that right now, please. Shift left, shift down. X's get subtracted by 2. Y's get subtracted by 1 of the original values. Okay? Is it making sense? Okay, so this is the third one here. Let's see. So that should be shifting the original. Okay, but I don't see the third one. And this is the original, right? So this is the one where you shifted to the right. This is the one where you shifted down. Where's the one where you shifted both? This is the third one. We're looking at that one now. Number 3, go. Come on, let's get it done. I should be shifting both left and down. Yes. Yeah, the original points. No, not the points that you came up with afterwards. It's the original point. So the points that we listed at the start, those are the points I want you to work on. Yeah, take 2 from each X, take 1 from each Y. Does that make sense? So remember now, for this one, every X value adds 1, every Y value adds 4. Okay? All right, reflections of functions. So we've done moving the function up, down, left, right, horizontal translation, vertical translation. We've done that. But now we're trying to move things in a different way, or to transform things in a different way by reflecting them. You've probably heard of reflections before, so you have an idea of how this works. A reflection is a transformation of a graph over a line of reflections. There's always some line of reflection, and all the reflections we're going to do today are on either the x-axis or the y-axis. So we'll start up by reflecting in the x-axis. So reflecting the x-axis, we put a minus in front of the whole function. So when you put a negative or change everything in the function to the opposite sign, that's going to make it reflect on the x-axis. And we'll see what that looks like in a minute. So let's draft the y equals, or f of x equals the square root of x function. So we're all going to do that together now. All right, let me put this thing back in mode for that. These are the points that we're going to be using. All right. So we're going to use all these perfect squares. 0 goes to 0, 1 goes to 1, 4 goes to 2, 9 goes to 3, 16 goes to 4, and so on. We can't plot every single point, but we'll plot as many as we can. So 0 goes to 0. 1 goes to 1. 4 goes to 2. And 9 goes to 3. Okay, so it should look something like that. We've seen square root functions before, we know what they look like. So those are the coordinates that we use: 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. What happens when I reflect on the x-axis is that every single y coordinate, here's the surprising part, reflecting on the x changes the y's. Every single y value changes sign. So my x values don't change. My x values are still 0, 1, 4, 9, and 16. my y values now become negative. Well, 0 can't be negative, so it's still 0. But this becomes minus 1, minus 2, minus 3, minus 4. So all the y values simply change sign. Now, I didn't say they become negative, because if they were negative in the first place, they become positive. But if they were positive, they become negative. So what does that look like on the graph? Well, you'll see when you graph it. Right? I'll put that in red. So 1 minus 1 is down here. 4 minus 2 is down here. 9 minus 3 is down here. It looks something like that. So everything on top went on the opposite side of the x-axis. You're reflecting it on the x-axis. So if it was on the upper side of the x-axis, it ends up on the lower side of the x-axis. If it had been on the bottom of the x-axis, it would have ended up on the top of the x-axis. So that's what a reflection does. It just tends, if you look at the axis of reflection, it just goes on the other side of the axis of reflection, is really what it does. That's what a reflection does. Reflection on the y-axis, how is that different? Okay, that's different because now we're going to leave all the y's the same the way they were, but now we're going to make all the x's the opposite sign. The x's are the ones that made the opposite sign. So first of all, let's go ahead and graph the y equals square root of x function again. So 0, 0, I start off with purple again. 1, 1, 4, 2, and 9, 3. Now, remember now, my y values are not changing. So it's still 0. I'll use red for that, actually. It's still 0. It's still 1, 2, 3, and 4. But every x value now is going to change sign. So it's going to become, well, 0 is still going to be 0. But minus 1, minus 4, minus 9, and minus 16. Okay? So that means that the function is going to look more like this. And remember, what we're doing is we're actually putting a minus in front of each one of these x values first. That's what we're doing. So, excuse me, that means that 0 is still 0. Minus 1 is now 1. Minus 4 is now 2. Minus 9 is now 3. So it looks something like that. Oh, I didn't put in the original graph. Let me do that now. So this is the original in purple. The red represents the reflection across the y-axis. So now if it was on the right of the y-axis, it ends up on the left of the y-axis. Now some of you are thinking, but how are we going to take the square root of a negative number? Well, remember that you're putting a negative in front of each of these x's. So it's negative, negative 1, which becomes positive 1. Negative, negative 4, which becomes positive 2. That's why these are all going to be changing to positive when you take the square root. And that's why you have those values there. So if you reflect across the x, you change side. You go from the upper side of the x-axis to the lower side of the x-axis. If you reflect across the y, you go from the right side to the left side or from the left side to the right side. Now, some points are what we call invariant points. Oh, by the way, let me write down what we're doing in each one of these. I should have done that from before. This first one was a reflection. I'll write that down. And you should too. Reflection on x-axis. And this one is reflection on the y-axis. Okay? Reflection on the y-axis. Now, we asked about invariant points. Any point that was on the axis of reflection doesn't change. Because remember, every time you have a reflection, it changes from being above to below or from the left to the right or right to the left. But if you're actually on the axis of reflection, you can't move. Right? You can't go to the left of something that you're on. You can't go to the, so if you're on the x-axis or you're on the y-axis, then you don't change. So let me answer that question now. Which is the invariant point? Let me go back up to the top here. Which point from the original table did not change? Which point is invariant is the question. Yes, Charmaine? The 0, 0. So the invariant point, INV point, was the 0, 0. And by the way, it's the same thing down here. The invariant point is also 0, 0. Hope everybody can see why. It is on the axis of reflection, yes. Oh, no, absolutely not. Absolutely not. It just depends on which point is on the x-axis for it to be invariant, on the or x or y-axis. Okay, let's keep this going. Next page. Here's a summary table. If your function was a linear function, f of x equals minus x would reflect on the x-axis. If you put the minus in front of the x before you do the function, it's on the y-axis. The same thing here, right? So look at each of these. And look at, do the summary table on your own. Sometimes after reflection, it actually looks the same. Let's put some points in this graph for x squared minus 5. Let's go with, let's see now. Let's use some points like maybe, we'll start, actually, we'll just use regular x values here. We'll use x values of minus 3, minus 2, minus 1, 0, 1, 2, 3. We'll use those values. Right? I want you to fill in the table that would result from x squared minus 5 for these values, which means minus 3 squared minus 5, minus 2 squared minus 5, minus 1 squared minus 5, and so on and so forth. Fill in that table of values for that for me now. You don't need me to help you with that. Then we're going to talk about what would happen if we were to put a negative in front of that whole function. How would the function look after I did that? Right? So be careful now, folks. Right? Because I see somebody making a mistake already. If I take minus 3 and I square it, I'm going to get 9. Right? And then 9 minus 5 would be 4. All right? Is everybody clear on that? Make sense? If I square minus 2, it's going to be 4. And then 4 minus 5 would be minus 1, and so on and so forth. So fill in that table for me, please. Fill in that table. Yeah, draw the graph for me, please, everybody. And this graph shouldn't surprise anybody. It's really the x squared function that's been shifted down by 5. That's really, it's a translation of the x squared line. So it really just shifts the whole thing down by 5. So I'll draw mine as well. Put all my points in. Where's my stylus? So that's 1 minus 5, which is minus 4, minus 5, and that should be minus 4, minus 1, and 4. So minus 3, 4 is here. Minus 2, minus 1 is here. Minus 5 is here. I'm actually going to use a step pattern. Across 1, up 1. Across 1, up 1. Across 1, up 3. 1, 2, 3. And across 1, up 5. 1, 2, 3, 4, 5. So here comes my graph. All right, now, based on what I've said to you, putting this minus in front of the whole function, should that be a reflection on the x or a reflection on the y? Go back and look again at what I said when I was talking about the two types of reflections. Okay? Is it a reflection across the x or reflection across the y? Yes, Abel? Yeah? It's a reflection on the x-axis. Thank you very much, and thank you very much. So if it's a reflection on the x, which it is, it's a reflection on the x-axis, which one of these is going to change sign? Is it the x values or the y values that change sign? Which one changes sign? Yes, the y values change sign. So every x value stays the way it is. X values, if you're reflecting across x, do not change. So it's still minus 3, minus 2, minus 1, 0, 1, 2, and 3. But these, I didn't say they become negative. They change sign. So what that means is that everyone that was positive becomes negative, and everyone that was negative becomes positive. Are we clear on that? Everybody okay with that? Yes? Rosie, we're good with that? Makes sense? Go ahead and put your points in now. Right? All my x values were the same. All my y values are going to change. Yes, AJ? How is it? What? Sorry? How is it across the x-axis? Okay. Let's go back to the first page. Actually, everybody should be putting their values in the meantime. Let's go back to the first page for a second. It says here, if your function is f of x equals the square root of x, if I put a negative in front of the original function, I'm reflecting across the x-axis. The original function is the one that we just had, and I'm putting a negative in front of the whole thing. Okay? That means it's a reflection across the x-axis. The whole function, so here's my whole function right here, square root of x. I'm not putting a negative right just on the x. I'm putting a negative across the whole function. That reflects it across the x-axis. Okay, so let's try it and see how it works out. Let's see what it looks like. So, where am I? So my 4 becomes minus 4. My minus 1 becomes positive 1. My minus 4 becomes positive 4, and so on. Minus 5 becomes positive 5. Minus 4 becomes positive 4. Minus 1 becomes positive 1. And 4 becomes minus 4. That all my x values are going to stay the same if I'm reflecting across the x. All my y values change sign. So what was negative becomes positive. What was positive, pardon me? You're saying that this is a reflection on the x. So the whole function gets a negative in front of it. What used to be just x squared minus 5 becomes minus x squared minus 5. Okay? Excuse me. Okay, go ahead and draw that for me now. See what that looks like. And then when you look at it, ask yourself, does this look like I took this original function and flipped it over the x-axis? Does it look like that? Is that what it appears to have happened? Right? Yes, Jay. Yeah, you caught me on that one. I should have arrows on the end of my graph. Yes, yes, yes. Because I'd be the one saying you must have your arrows, so I need to have my arrows in there as well. All right, so let me do that. I'm going to put my red line in now, which is my new function, minus 3, minus 4. Down here. Minus 2, positive 1. Here. 0, 5. There. Across 1, down 1. Across 1, down 1. Across 1, down 3. Across 1, down 5. Okay? Are we good, folks? I have one more thing I want to try before we wrap this thing up. Right? So that's a reflection. What you just did is a reflection across the x-axis. Now, go to the next page. By the way, don't lose these because we're going to finish this up tomorrow. No, that's not the page you want. The original function is x minus y, sorry, rubbish, is x minus 1 squared minus 3. We're going to get to what that looks like in just a minute. My question is, what if I put a negative just in front of the x itself? Just that one thing. Oh, I'm not going to change anything else, but what used to be just simply x becomes minus x. And then everything else is the same, minus 1 squared and minus 3. What do you think is going to happen this time? Yes. Yeah. In front of the variable, yes. What's going to happen? What would you say? So you agree with him then? And you agree? Oh, do you think that's what's going to happen? That's because you're all right. Good. All right. Well, first of all, before we put our table together, there's a very easy way for us to draw this. And since we're kind of coming up to the end of the class, let's see if we can draw this the easy way. This is what we call vertex form. Where's the vertex? Where's the vertex of this equation? Yes. 1 comma 3. 1 comma negative 3 rather. Let's put that in. 1 negative 3 is this point. I'll put that in red. 1 comma negative 3 is right here. Everybody agrees with that, hopefully? Right? From that point, let's use the step pattern. Right? We told step pattern before, which we even reviewed at the beginning of the year. Step pattern is 1, 3, 5. You have the vertex. The vertex is the 1, positive 1, negative 3, right there. You can go across 1, up 1, across 1, up 3, across 1, up 5. We're going to do that right now. So we'll put the table in afterwards. So across 1, up 1, across 1, up 1, across 1, up 3, 1, 2, 3, across 1, up 3, 1, 2, 3, then across 1, up 5. 1, 2, 3, 4, 5. Cross 1 up 5. 1, 1, 2, 3, 4, 5. I'm ready to draw my graph. Right? Now, yeah, we could do a table of values and all that other stuff. Every single point, if I'm reflecting this on the y-axis, every single point is going, and this is sort of the quick way to do this. Every single point, remember, I'm reflecting on the y, so the x are the ones that change sign. Every single point is going to be on the other side of the y-axis. So I wonder if you would be able to draw this without even the table of values. Challenge yourself to see if you can do that, right? Take each point and think, remember now, I'm reflecting across the y-axis. All my y values stay where they are, but my x values are going to switch over to the other side of the x-axis, the same distance away, but on the other side of the x-axis. So for instance, I'll give you an example. This point right here is 2 away from the x-axis on the left. So if I want to reflect on the y-axis, shouldn't I put it 2 away from the y-axis on the right? Does that make sense? So we'll do that. I'll use a purple for that. So here's where my image is going to be. This point here used to be 4 away from the y-axis on the right. I'm going to make it 4 away from the y-axis on the left. 1, 2, 3, 4. Okay? Try the same thing with the other points. Right? Now, there's one point that's going to be invariant, by the way. Can anybody tell me what that invariant point is going to be? It's different from the 0, 0 that we've been doing before. Yes, Manael? The 0, -2, because it's on the y-axis. It's going to be invariant as long as it's on the axis of reflection. That one doesn't change at all. That one stays exactly where it is. Okay, let me put some other points in we're running out of time here. This one is 1 to the left. I'm going to put this one 1 to the right. This one is 1 to the right. I'm going to put it 1 to the left. This one is, what is this? 1, 2, 3 to the right. I'm going to put it 3 to the left. 1, 2, 3. And this last one here is 2 to the, I'm going to put 2 to the left. 1, 2. Here is my new graph, which has been reflected across the y-axis. Now, what we'll do tomorrow when we come back in is we're going to make sure the points match up based on what we're seeing here. We just use step pattern, and then we just kind of use what we understand about reflection to say, okay, if you're on this side of the axis of reflection, you're going to be on the other side of the axis of reflection, the same distance away.